Hello, everybody. Welcome to today's webinar. Thank you for joining us today. So allow me just to introduce the webinar with a few words before giving the floor to our guest speaker. So this webinar is part of a series offered by the BDVe project in the scope of the support that this project is giving to the BDVe PPP. So the aims of this webinar are basically to showcase on the first aim is to showcase the projects funded under the PPP topics and the main results that they can provide to the community. Also providing technical and business insights on how big data technologies can be applied to several sectors or domains. And last but not least, tackling different hot topics or dive into cross-cutting topics of interest for people that are interested in big data in general. So we have a periodicity of more or less webinar for each month. If possible, we would like to have these webinars running on Tuesdays, the first Tuesday of each month at 12. But of course, it will depend on the availability of speakers and the potential coincidence with other events that may happen at the same time. So we will be posting the webinars as we have them. In principle, let's get started by giving a few housekeeping items. Basically, we are going to use this tool, GoToWebinar. You have any troubles using the tool or something that goes wrong from your end, do not hesitate to write in the chat. I will try to have a look at the chat all the time just to give you support. Or just send an email to me. You have my email on the invitation that was sent to you. All participants, the speakers, will be muted to avoid echoes and background noise as normal. And but if you have any questions to the speaker, please type the question into the question chat that you have in your user interface. I will be collecting all the questions, and if we have time at the end of the webinar, we will try to answer. If we are not able to do so during the live webinar, we will try to compile all your questions and respond to them later, and maybe provide some extra file with the questions on the website of the BDVe. Also, you will be asked with a couple of questions now at the beginning of the webinar, just to know our audience and what type of interest you have. And also, you will have a very brief survey at the end of the webinar to provide us with feedback of the results of the webinar. So basically, this will help us to improve the whole round of webinars and try to understand the audience and the topic. So allow me to start by asking you a couple of questions. So let me issue the first one. You just have to answer. The first question is about what are you interested in, and you will be prompted with a couple of or three different type of questions. Please answer to them. I will give you like 15 seconds, and once we have the answers, I will tell you more or less the type of audience that we have today. So I see that people are responding. I give you just a few more seconds. Okay, so I am about to close now. So this is closed. What I know now is that 47% of you are most interested in technical things related to big data, 71% to business or sectorial application of big data technologies, and around 30% about crowdsourcing. So this is an input also for our speaker later. And the second question and last question that I would like to you to respond is about crowdsourcing. So what do you know about crowdsourcing? Have you used crowdsourcing tools? So please answer to this particular question with a yes or no. So you have used crowdsourcing tools, just answer yes. I see that people are voting at this point, and the no is winning. So I'm closing now the poll. Basically, what you answer is that 75% of you didn't use in the past crowdsourcing tools. So 25% yes. So this is all about the polls. So what we would like to do now is to show you and introduce you the speaker today. Basically, we are going to talk about how human input can make a difference in the data value chain. For that, I have the pleasure to introduce you our speaker, Professor Elena Simperl from the University of Southampton. Elena is going to provide us with an overview of one of the projects that he's dealing with, Project QROWD, where human input is the main aspect of the entire project, along with some other experience and techniques that she's able to provide us with a very good insight on how to use this human input in the loop. So Elena, without more delay, I just pass the floor to you. So I will provide you with the presenter capabilities. Just 1 second, I change presenter. And now you should be able to show your slides. Thank you.
Hello, everyone. And thank you for giving me the opportunity to speak today. I'm just going to move this thing to the side of the screen. 1 second. I'm going to talk today about the human factor in big data, based on the work they've been doing in an innovation action that is part of the Big Data Value PPP called QROWD, but also following on my broader range of experiences in using crowdsourcing and human in the loop to improve the capabilities of data-driven systems. I guess lots of you are here because you're interested or working in big data and are part and very familiar with what we call the data economy. This is an economy that has been growing very rapidly in the last 10 to 15 years, and we have seen data value chains in a range of sectors as drivers for growth, for innovation, for change, having a transformative impact that led to new digital infrastructures, new types of businesses, new ways of doing politics, new monopolies perhaps, and new ways to interact in society. I hope you would also agree with me that data in all its volume, variety, velocity, and veracity is unlike any other resource in the ways it is created and refined and valued and exchanged. And this makes the economy and the underlying marketplaces much different than the flows and environments and ecosystems that we're used to, demanding new approaches from regulators. Just to give you an example, which is close to the QROWD project, data and the availability of data technology has fundamentally disrupted the transportation sector. In Europe, we have hundreds of smart cities that have set up infrastructure and have now access to more data than ever before, which they use to inform policy and to design better services for their citizens. At the same time, the car industry is undergoing fundamental change. We see self-driving vehicles electrified cars, connected cars, all of which are creating platforms and are generating data that can be used in all sorts of interesting ways in combination with machine learning and artificial intelligence. So transportation is one of those areas that affects many industries, where we see data value chains and a data economy emerging that can lead to innovation and growth. There are many challenges ahead, though, and I have classified these challenges into two areas. The data availability ones are related to the question of do we really have the data we need? And in fact, those of you who are familiar with AI, machine learning, and data science know that no matter how much data we're collecting, there's always data that will be missing, sometimes critical for some applications, in particular when it comes to capitalizing on AI and machine learning. So in many areas, we might have raw data, but labeling this data to train and validate algorithms is still quite costly. Data is not always at the level of quality that we would want, and integrating it across different sources to make it more useful still has lots of technical limitations. So all these challenges around data availability are mostly technical challenges. So many of the tasks around data collection, curation, labeling could be potentially automated, but technology has limitations. The second class of challenges, I've labeled it as data use, and it refers to a series of non-technical challenges, challenges that are legal, economic, social, even ethical, and refer to how do we use all these vast amounts of data that we have at our fingertips to work on things that matter, to make decisions that work for a range of stakeholders, to enable the free flow of commercial data, of shared data, to build interesting and useful data value chains, and to innovate responsibly, to use data according to ethical and privacy and data protection principles that make sure that the resulting products and services are going to be accepted by its users. So this can have, not solving these challenges can have huge implications. And again, I have used examples from transportation. We have lots of data, but now we have, through articles in media and ongoing debate, we know a lot about the quality of the data and the implicit biases in the data. So on the left-hand side, you have an example of an application called Street Bump, which is collecting information about potholes in a city. This information is used by city planners to identify potholes and needs to repair streets in a much faster and immediate ways than using traditional collection methods, which would be surveys, so sending civil servants on the street to survey and map the area. So while this sort of digital product has enabled cities to collect lots of information from citizens, if you analyze this data, the conclusion that you're drawing is that wealthier areas in a city have lots of potholes, a much higher number of potholes than perhaps other areas. So this sounds surprising, but it actually points to a bias in the data, because this application is used by particular demographics in society, and the way the data is collected does not ensure that the city planners have full coverage and a full picture of what is going on. So limitations in the data, having access to a representative sample of the data is quite critical. Another story that I could mention at this point is around smart cities and so-called living laboratories. So smart cities are collecting lots of sensor and citizen data, but there are also voices and increasing concerns around how this data is collected and whether the residents, the citizens, the tourists that live in those areas, whose data is collected through smart cities infrastructure, are empowered and have the right means to participate and have their say in the way the data is used. And finally, without solving these technical and non-technical challenges, we even risk that some of the successes that we already know about AI and machine learning in various areas would peak, and the technology would be less accepted. So without training data, without critical mass of training data, without means to make sure that the algorithms are applied to solve problems that matter to broader parts of the population, we risk that this technology is going to be less accepted. So this is why studying the human factor related to technology, to data technologies in particular, is so important. And fundamentally, it helps with three main areas. It helps get more and better data. It provides the critical resource that is labeled data that helps train and validate machine learning algorithms. And beyond that, it offers also a framework and guidelines on how to make citizen engagement, customer engagement more effective and empowering. There are a range of approaches on how to use human factors in technology, and I have listed here just the subset. Citizen sensing, it might be something that you have heard of. It basically refers to a set of methods to collect typically location-based information from people based on mobile devices and wearables. So fundamentally, you would install a tracking app voluntarily on your phone, on your device, and you would give the data holder, the city, or a different organization, the permission to collect these data flows that would then help them identify patterns and behaviors and areas of the city that are more populated or more popular in particular contexts. Urban auditing is another area. It is again related to data collection, but instead of collecting data about citizens, about people and what they do and where they go, it is about collecting data about a city, about an area. So for example, getting up-to-date information about the status of bus stops, or where all parking spaces are located in a city, where all mailboxes or other points of interest are located. So information that helps city planners know their city better and get this information about these different objects of interest in a timely manner. Participatory democracy, I mentioned earlier, broader engagement. So this is a form of crowdsourcing where an organization would, in particular a public sector organization like a city or a local government, would reach out to people, to its citizens, to get a sense of the type of services they really need, the types of concerns that they have, in order to prioritize what sort of data sets they open, what sort of data sets perhaps they need to collect, and how to use the data that they have in ways that really solves problems that are relevant to people's lives. And very related to that is an area or an approach called open innovation, which applies more broadly, so not just to government and the public sector, but to any organization that is interested in getting broader feedback and input into some of the problems that they solve, into product design, into how they should customize specific products and services, and so on and so forth. Crowdsourcing is a term that is often used in relation to human factors. It is related to the areas that I have mentioned earlier, but it typically refers to a problem-solving approach, where an organization reaches out to a crowd, so to a large number of people, typically through an open call to solve a particular problem or get opinions on a particular matter, or collect data or solve several other tasks. And we're going to see more examples of crowdsourcing in the rest of this presentation. Thomas also mentioned at the beginning in the introduction a term called human in the loop. This is a technical term. Human in the loop architectures are IT systems, basically, that use machine learning or data analytics in combination with crowd intelligence. And this means, for example, developing so-called active learning features in a system where human involvement is sought to help a machine learning algorithm improve their performance. And later on, we're going to see an example from Crowd where we do just that. So this is just a small set of approaches that are related to what we call human factors in big data or in technology. And just for simplicity's sake, for the reminder of this presentation, I'm just going to use the general term crowdsourcing to refer to all of them. Organizations struggle to use crowdsourcing effectively. So I have used the example of smart cities before, but in virtually any sector of the economy, organizations are implementing more and more sophisticated IT systems that use data and in novel and interesting ways, that use machine learning and AI to detect patterns, detect anomalies, predict behavior, and innovate more broadly. When it comes to adding that human layer on top of the existing technology to solve the sort of technical and non-technical challenges that I had mentioned earlier, they struggle. And there are various reasons for that. Adding a human layer to technology is not straightforward. It requires insight from a range of disciplines. Organizations do not have perhaps the right department with the right skills and teams to bring together these different ranges of insights from different disciplines. But fundamentally, we are dealing with some really hard questions that we need to answer if we want to use crowdsourcing effectively. So if we think technology is hard and complicated and using deep learning or integrating across thousands of systems is complicated, adding humans in the loop will not make the problem easier. In fact, it's going to create a whole new set of challenges that are fundamentally different, because we are dealing not with technology, we are dealing with people, with all the strengths and weaknesses that this approach implies. So when trying to use crowdsourcing, say to implement the human in the loop architecture, there's lots of questions that organizations need are confronted with, and I'm going to go through some of these in the presentation. So I've mentioned that there are a whole range of approaches that one could use to get humans involved in different processes and decisions. So one question it is what form of crowdsourcing to choose, what works when and where, and shall an organization perhaps look into a mix of different forms? How to engage people in the first place? What motivates them? Why would they care? If you reach out to them on social media to get feedback on a new product, if you would want people to label images to build a machine learning classifier, why would they do it in the first place? What sort of motivations, what sort of incentives could you create to drive participation? How do you control quality? Crowdsourcing is fundamentally a new way of solving problems that goes beyond existing management and organizational structures and processes. So you reach out to people you don't know, that don't work for you. They are not your contractors, they are not your business partners, They're people who contribute sometimes voluntarily to the problems you crowdsource. So the question of, is the solution they are proposing good or good enough is quite relevant, because you will not have the same sort of quality assurance methods and mechanisms that an organization has put lots of effort into defining and tuning. Does crowdsourcing have to be in real time? So some problems do require human involvement in near real time. So if you are in a disaster management scenario, in a crisis management scenario, and you're reaching out to people to say identify areas that require immediate intervention from a drone feed, video feed, then you would want those answers to reach you very, very quickly. If you're a media organization who is working on breaking news and you've received a video and would like to verify whether it's correct, it's legit or not, again, time is quite important. In other cases, like urban auditing, time is less of an issue. So if you're looking to have an accurate map of different points of interest in your city, the alternative is to do traditional surveys, which typically take years to collect and consolidate the data. So there, if you have the data within reasonable time boundaries, like days, weeks, months, you are still going to achieve a better performance than using traditional approaches. And fundamentally, can we afford to use crowdsourcing at scale? So there, it might be worth making the point that crowdsourcing is sometimes paid. So you cannot rely on social media users, on volunteers, on customers to help you solve problems without any rewards. And if you do this sort of open innovation and crowdsourcing projects a lot, like most large organizations do, then you will have to think about the costs and compare them with the benefits. A good example here is, again, machine learning. So if you're looking to leverage machine learning, you need huge amounts of data, huge amounts of labeled data, millions of labeled images and records, and creating those labels, especially if you have big data sets, is going to have resource implications. So now, just briefly about Crowd, which is the context in which we have looked at some of these questions. It is a 3-year project that is part of the Big Data Value PPP. It brings together 8 different organizations from 5 European countries, coordinated by the University of Southampton. Fundamentally, we develop smart city solutions that combine crowd and computational intelligence, and I'm going to give you later on 2 examples of this sort of combinations. And we pilot this approach in transportation. We have a pilot with a medium-sized smart city in Italy, the city of Trento, and we have a second pilot with a leading navigation and traffic management service provider, which in this case is TomTom. So the city of Trento are implementing citizen dashboards and dashboards for civil servants, which bring together data streams from various sources. These data streams are enhanced by data collected from citizens or analyzed by citizens for different purposes. TomTom is using the same sort of crowd computational workflows to improve their road information services, to have better data, to have label data to train their prediction algorithms. Crowd delivers a number of interesting results. We are building a platform to support data value chains in any sector. And this platform features many of the components that those of you who are familiar with data technology know about, from different ways to collect, to acquire and store data, to link discovery and data fusion, different forms of machine learning and data analytics, but also on top of this, an integrated layer of crowdsourcing features, as well as methodologies for open innovation and value-centric design. The platform that we're developing features human-in-the-loop components at every step in the data value chain. So from data acquisition and generation to curation to fusion to analytics, we develop algorithms which are state-of-the-art in terms of their performance from a technical point of view, but that integrate and support the deployment of human-machine capabilities as well, and offer interfaces that allow us to use different types of crowdsourcing platforms and services as part of the technology. So you could imagine a machine learning algorithm that takes a camera feed from a city and wants to get a sense of how heavy the traffic is. There are parts of this task that can be done with computer vision, recognizing the different cars and perhaps also counting some of them. But for this algorithm to work very well, it needs labeled data. So we're building workflows where the machine learning algorithm is able to automatically, to seamlessly seek help from people. So it's reaching out to existing crowdsourcing services like Figure 8 and is publishing so-called micro tasks there, which are basically online forms through which people can label those images from camera feeds and recognize cars and count them. And these labels are then used by the machine learning algorithm in a seamless fashion to improve its performance. To do all this, we have put together a methodology that has 4 components, and I'm going to go through each of them. So the what component refers to the question of what should you seek human involvement for? And in general, the answer is any sort of task that you wouldn't be able to complete using just technology, computers, or in-house processes. The who component refers to the different types of audiences you could reach out to. So those 25% of you who have used crowdsourcing might have heard about Mechanical Turk or Figure 8. So paid crowdsourcing where people register to solve simple tasks like label images or classify tweets. Crowdsourcing goes much further than that. So it involves all these different approaches, which I have mentioned earlier. But at its core refers to approaches where an organization is seeking help through an open call. So you are not reaching out internally to the teams in the different departments that are typically approached to solve particular classes of problems, but you're reaching out to people from outside your organization, which means that you have potentially a much larger pool of resources available, but you also have to pay attention to the fact that you don't have the same ways to engage, to manage, and motivate performance. The how component refers to the actual implementation of crowdsourcing, the different types of workflows, the way you assess the answers from the crowd and aggregate results. And finally, the why refers to that question. Why would people help you? Why would they care? So, and getting an understanding of the tension between the interests of your organization and why, and the reasons why you are using crowdsourcing, and the intrinsic or extrinsic reasons why someone who's not from your organization would help you. How to use this methodology. So fundamentally, this is a guide for organizations that are interested in increasing participation via crowdsourcing. This could be local government that seeks input from their citizens. It could be technology providers that want to implement human-in-the-loop architectures to collect label data to improve machine learning algorithms, but also providers of apps and services that require user-generated content or data collected from citizens and want to motivate people to share their data with them. The methodology can be used in different ways. At its core, it is a process model. So I've mentioned the 4 components: the what, the who, the how, and the why. The methodology basically is a model that starts with the what, encouraging you to think about specifically about the reasons why you're using crowdsourcing, followed by the who to guide you through the selection, identification of an audience, of a crowd to reach out to, which then determine the how. How are you going to implement? What platform are you going to use? How are you going to validate the answers and aggregate the results? Every what, who, and how decision impacts on the why. So depending on the sort of task that you seek contributions to, depending the type of platform you're using, you will have to assume that people will be more or less eager to contribute and design incentives to change this behavior. The methodology itself can be used without the crowd platform, which I've mentioned earlier, and it just helps understand the space, specify goals, decide what forms of crowdsourcing to use, and roll out crowdsourcing projects. So I'm going to go through the 4 components now quite briefly, and I'm going to use 2 examples from the crowd project. The first example is from an area called urban auditing, which I've introduced earlier. So in this case, we are an organization that is looking to collect up-to-date information about parking in a city. And the second example I have is a machine learning example to predict something called model split. So model split refers to how people use different means of transport in the same trip. So if I'm traveling now from my home in London to the Eurostar in St. Pancras, I will use probably 3 different means of transportation. So model split has to do with understanding which segment of that trip, which portion of that trip will I walk, which portion will I take the bus, when do I switch to the tube. And this helps city planners get a much more nuanced understanding of how public transport and roads are used and plan accordingly. So now I'm just going to go through these 4 components of the methodology: the what, the who, the how, and the why. So I said that the what refers to what do you want to crowdsource, and there are fundamentally 2 types of tasks. It's either something you can't do using traditional means in-house in your organization, something that requires broader engagement, where having feedback from customers or citizens would be helpful, or something that you can't do fully automatically. So some sort of data collection or analysis task where you might have an algorithm, but it doesn't work as well as you would want. So in our examples, for parking, we need a data set, an up-to-date data set with all parking spaces in a city. This is slightly different than having the availability of parking spaces right now. And the reasons why we want to crowdsource is because surveys, as cities do them since forever, are way too costly, take years to put together. For the model split, what we need is first the actual raw data. So it turns out no one, when you talk to big map or traffic management service providers, they have information about what people, how people travel from A to B, but they actually don't know how those trips are split into different means of transport. And they also don't have the label, so they don't know for each trip segment whether it was done by bike or by train or in a car, in a taxi. So this data is really not available and is needed to train any sort of intelligent traffic management or route planning tool. Right, so if we talk about the what component of the methodology, you would need to answer questions such as, what is the task am I trying to solve? And can I solve it via other means? You don't have to use crowdsourcing necessarily to collect or curate the data. Maybe you could buy that data or similar type of data from someone else. You could do the labeling in-house. You can set up a small team of people you train. You could actually build more robust algorithms to use less or noisier data. In many cases, crowdsourcing is still a good idea, but at this stage, it is really, really important to just analyze the alternatives as well. Once you have decided that the task is worthy of crowdsourcing, you need to think about the different types of audiences you would address. In general, like I mentioned earlier, you are reaching out to people you have not met before. So these are not people in your organization. And the reason you're doing this is because you have access potentially to a larger pool of resources. And that scale helps you solve the problem faster. So if you have 1 million images that you need to label, if you reach out to your 5 labelers in your organization, this is going to take a number of days or months. If you go to a crowdsourcing platform that has 5 million registered crowd workers, you would get that done in an hour. Some tasks, nevertheless, will have constraints. I have mentioned time-sensitive crowdsourcing earlier, but sometimes you will need specific knowledge, language knowledge, location insight, or other types of skills. What does this mean? This means that the potential pool of resources that you have is actually much smaller, and getting the job done will take more time, or you would have to pay more to get access to those people that have the right skills. So let's go back to our examples very quickly. And if we're thinking about parking, you could think of a range of different target audiences for this. If we want to have a parking data set for a city, you could think about the OpenStreetMap community as a crowd you want to reach out to. You could think about people who are familiar with that area. You could think about drivers that use a sat-nav and drive through the city. You could think about using paid crowdsourcing services, professional services. You could use something like social media, where people complain about the parking situation on a street as a signal. For labeling trip segments, again, you could think about reaching out to people who drive or use public transport. You will need to find a way to actually reach out to them, and that can't be via phone or traditional survey techniques, because that would be too costly. It would take too much time. So you need to find a way to reach to these people and ask them, motivate them somehow to tell you about their multimodal trips and label basically the data you need for your algorithm. So questions that are relevant to you here is really, who is my crowd? Is it a professional set of crowd workers, a set of customers of my organization with whom I engage regularly via social media, volunteers, an existing community? How do I reach out to them? Do I use social media? Do I use email? Do I have already an app, a product, or a service, and I reach out to them, to the customers, to the users via usual channels? What sort of requirements do I want? What sort of skills does the crowd need? Do they have to speak a particular language? Do they have to be in a particular location? Do I need all the answers by the end of next week? And so on and so forth. In terms of process, there's lots of details that are important here, but fundamentally at this stage, it is about understanding that there are different ways to implement, roll out the crowdsourcing project. You could use specialized platforms like Mechanical Turk or Pybossa or Figure 8. You could, in some cases, use social media or existing engagement channels with the customers of your organization, or you could extend existing systems with feedback loops for people to answer questions, provide opinions, provide comments. There are different components that need to be taken into account. So there are questions around who would solve each particular part of the problem. So if you have, say, 1 million images from the city and from the roads of the city, you would want to parallelize that task. So there is a question perhaps of how many images would each participant receive, and whether there is a random allocation for that, or an allocation based on other means. There are also questions around how do you collect all the different answers and how do you aggregate them into a correct answer. So for our parking example, we have developed a number of systems to collect the data we need. One of them is called the Virtual City Explorer. So we have actually built our own crowdsourcing platform for urban auditing, where we recruit people from existing paid crowdsourcing platforms like Mechanical Turk and Figure 8, and we ask them to explore a virtual map, a virtual city via street view imagery, and they start at a certain point, and then they have tasks like you see here the instructions on the screen. We tell them we need you to locate parking spaces of different kinds on the street and then take a picture or mark that area somehow. And then we collect all the data and we validate the parking using heuristics, but we also analyze user behavior to propose optimizations. Another example for parking as well is called iLog. So this is an actual Android app we have developed in QROWD to do citizen sensing. So what we're doing with it is we're collecting location information about people's movements with their consent. And then we've also set up a citizen panel, an innovation lab in the city of Trento, to reach out to people to promote this app and encourage them to use it. So we're using this app to launch a series of weekly challenges where, for example, in one of these challenges, we ask people to take pictures of parking spaces, specific types of parking spaces, which we then validate and aggregate into a data set. The other example that I had was around model split. So on the left-hand side, you see the hybrid workflow we're implementing, which consists of a combination of a supervised classifier, trip data, which is collected through the iLog app. So we have lots of trips from citizens from Trento, and we know via the accelerometer function in the phone, we know when they are walking or moving faster or slower. From that, we have an initial understanding of the potential segments. So when do people stop? When do they potentially switch means of transport? But then we need to ask people to label those segments. So with iLog, we implement a gamified challenge, and we're experimenting with different interfaces, which you can see on the right-hand side, to get the best way of how we ask people to give us the information about which segments in their trip they have used what a particular means of transport. So similar questions for you as well in your projects. Do I need a new system? Am I using a specialized crowdsourcing platform? Can I just add a feedback channel or a crowdsourcing engagement channel to my existing product or service? How do I allocate tasks to people? Will they choose freely how to contribute, or do I set specific tasks to specific people based on their skills? And is there a way to recognize good answers, good solutions easily, and to reward them? The final component in this methodology refers to the reasons why people would contribute in the first place. And from behavioral economics and psychology, we know that basically people do things for a combination of money, love, or glory. So money refers to any sort of external reward or incentive. Love refers to an intrinsic motivation to do the task. Glory is rather extrinsic and has to do with reputation or standing in a group or a community. And from the same disciplines, from empirical studies, we know that if the task that you're asking people to do is intrinsically motivated, so if people love to do it, if they associate some sort of standing or reputation with it, then you don't need to incentivize behavior a lot. We also know that when incentives are used, increasing them, so having higher rewards, but also adding a reputation layer, would not necessarily produce better results, but would produce faster results. So it is this sort of insights from behavioral sciences that give us hints into how to motivate people. In our examples, we're using a range of incentives. So the city of Trento and any smart city in the same situation has probably some form of innovation lab. Other organizations have customers that they are using in focus groups and for other activities. Those people are to a certain extent intrinsically motivated. In other cases, there are platforms, specialized platforms, where you can assign rewards, or existing communities that volunteer to help for tasks that are socially rewarding. These are the sort of questions that you would need to think about. So realistically and honestly, why would anyone care to contribute? The answer is easy, more or less easy, if you're using a specialized service and pay people, but even then you would have to think about the resources. If you have huge numbers of tasks to solve, like major internet players, they run hundreds of thousands of this sort of tasks on a daily basis on figure 8, so costs are an issue there as well. If you can define the task in a way, if you define a narrative that resonates with people, that is intrinsically rewarding, then there are other ways for people to engage voluntarily. This obviously reduces costs, and there is also a fundamental question around sustaining participation. Sometimes this is not needed. Sometimes once the label data set is created, you don't need updates very quickly. But in many other situations, like for urban auditing, for example, you will need to reach out to people over and over again to make sure that you have the information that you need. I'm going to wrap up now. So I tried to give you a really brief 45-minute presentation of a huge area that reaches out across a number of disciplines, IT related and otherwise. If we look at the big data and AI landscape today, the most sophisticated systems there, they are always bringing together some combination of machine and human intelligence at any point in the data value chain. So you see it applied to collect data that we otherwise don't have, like for model split, to enhance the data, to label it, but also to analyze it, like in image analysis, sentiment analysis, and to bring together data from different sources. We've put together a methodology to try to guide organizations to understand the design space and the different types of questions they need to answer to be able to use crowdsourcing effectively. This methodology can be used in combination with a crowd platform, which offers integrated support for hybrid data collection and analysis workflows with state-of-the-art technology and different types of hooks into crowdsourcing platforms. And Thomas also asked me to give you some further pointers if you're interested. So here I have the Crowd project website and the Twitter handle. If you're interested in using specialized crowdsourcing services, paid crowdsourcing, Figure 8 is probably a good example to start. I have compiled some of the guidelines which I have presented today in some of my earlier work in 2015 in this article. And then the last 3 bullet points are 3 books which are very interesting. The first one is more a history of crowdsourcing from the times when people were used to carry out computation to the times we're experiencing today where humans are augmenting technology. The Collective Intelligence Genome is a fundamental work by Tom Malone from MIT that basically talks about the 4 what, how, who, and why components I mentioned. And getting results from the crowds is a step-by-step guide into using different types of crowdsourcing. With that, thank you very much, and I think we have a few minutes to take some questions.
Thank you very much, Elena. I think this presentation was really good, and I think it gives a very good understanding also for what crowdsourcing can do for big data and for organizations. I think there is one question or maybe 2 on the in the chat, so let me just phrase it for you. So the question is, what kind of models are employed to predict modal split? And there's a further question related to that, about how you train models in Crowd, considering the type, the different trips that constitute the journey of a specific citizen in different means of transport. So this question is related to the how we you in Crowd create the models, and how do you understand the type of trips that the people are doing.
Right, thank you for that. I think it would be useful fundamentally to point people to the relevant documents that describe the details of the machine learning algorithm. So we're just in a nutshell, we're using a combination of a numeric approach and a symbolic approach. For the symbolic approach, we're taking sensor data that we collect through the mobile app, which is pre-processed, where we have, through the accelerometer data from the phone, we have an understanding of which portions of the trips are faster or slower, and we can identify potential segments, so parts of a trip where someone has potentially switched means of transport. So we can do that just based on the numerical data that we collect through the app. But then, and we're using that, and on top of that, we're also using a symbolic approach, which means that we layer that location data on top of geolink data and map data to get an understanding of what sort of points of interest could be in those areas where we assume, just based on the raw data, that someone has swapped the means of transport. So if we see a bus station, for example, if we see a taxi stand, if we see a train station in that area where there's been a change in speed, and how fast people are moving, then we could potentially assume that someone has left the tram and has got on a train. So it's a combination of numeric and symbolic learning. For the labeled data, so for those cases where the algorithm is unsure, or just to generate the initial training data set, we show people, iLog users, a set of questions every day where we show them basic, and they're various, this is still work in progress, and we're trying out different interfaces to make it easy for people to tell us about their journey. So we ask them, we show them a trip, we show them different segments we think that trip had, and then we ask them, was this first portion by foot, was it in a car, and if in a car, was it a taxi or was it your private car? And then based on these labels, we try to improve the performance. But like I said, so the actual details, perhaps Thomas, would be good to send the deliverables in Crowd, where we have explained this in more detail. What I would also want to add, perhaps as a final thing, is that there's approaches in the literature that are trying to do that. Fundamentally, the problem is not so much the classification as it is, so the machine learning part, as it is the availability of label data, and this is something we're trying to solve.
Thank you, Elena. I think we have already covered the topic of this webinar. We don't have much time left, so thank you very much. You have all of you have the information about where to find more resources in this web page that you can see already in your screens. We will provide the webinar recording in this web page, and also the material, presentation and links, so you all could dive into this in more details, as Elena was saying. So thank you very much to all. It's been a pleasure to have Elena here today, and stay tuned with the next webinars in the coming months.
Thank you very much.
Thank you.
Bye, everyone.
Bye-bye. Bye, everyone.